Now here we go, my friends. In question 5, it states that an answer sheet is provided for this question. Now, when doing this question, I'll recommend again that any question that states that you have an answer sheet, please look for the answer sheet. Okay, my friends? Good. Now, in part A, it states the diagram below is a scale drawing showing the line RT and the north direction on a playground. It is drawn to a scale of 1 centimeters to 30 meters. Okay, my friends, now here we have the drawing from R to T, and there we have our north direction. Now here it states, using the answer sheet provided, okay, part 1, they're asking us to measure and state in centimeters the length of RT as shown on the diagram, and that's an easy one, Mark. So basically what I'm going to do, you're going to take your rule and we're going to place our ruler. If you notice my 0 here, I am going to place it at the point R. Okay, so I'm going to place it exactly on R there, and I'm just going to measure there, and here I am getting a 6 centimeters. Okay, my friends, so for part 1 my answer is 6 centimeters. There we go. Now for part 2, let's just pull this out the picture. Okay, for part 2, they're asking us to measure and state in degrees the size of the angle that shows the bearing of T from R. Now they're asking us, let me just make a quick note. Oops, my bad. Sorry about that, guys. Sometimes we have a little bit of technical difficulties. Okay, now here, my friends, this is what I want to point out to you. Here we have the bearing of T from R. Okay, now the letter that follows from, that's where you're going to position yourself when working with bearings. Okay, so since R followed from, then I am going to place my protractor. Since they're asking us to measure that angle, I'm going to take my protractor and I'm going to place it at the point R. Okay, now bearings is measured from the north line. Okay, my friends, so the north line is the reference line or the 0 line. Okay, my friends, that's where we measure a bearing from. So I'm gonna have to place my protractor. If you notice how I position the protractor, now if you notice this point here, the central point here that I'm presently pointing on, must go on that point there. Okay, my friends, and my 0 line, which is this vertical line here, is going to sit on the north line. Okay, so that's the position you should take. So I'm going to place my protractor point on point there, okay, exactly in the middle, and my 0 line here, my reference line, is sitting on that line. Now let me just clear that for you. Now, my friends, if you notice, the 0 line here is on the north line, so now I can read my bearing. Now, if you notice, you have 2 readings, a reading on the inside and a reading on the outside. Now, the 0 on the respective line that's sitting on the reference line. For example, if you notice here, the 0 on the outside is sitting on the reference line, then it simply means I have to use the outside reading. Okay, my friends? If the reading on the inside, if the 0 was here on the reading on the inside, then I would have to use the inside reading. Okay, so that's just some important notes. So we are going to use the outside reading since that 0 is sitting on the north line there. So 0, 10, 20, 30, 40, 50, 60, and if you notice, it's exactly 65 degrees. Okay, my friends, so pretty much it's that easy. Let's just pull back down this here. Okay, hopefully you're seeing that. Okay, good. So oops, so that's a 6, oops, let's just make a note. Yes, my friends, so the bearing of T from R is 65 degrees. Now if you notice, when working with bearings, bearings are written in 3 digits. So if you notice, I have a 0 in front of my 65. Okay, that's how we represent a bearing. Okay, so pretty much that easy. So part 3, they are asking us now to calculate the actual distance in meters now. Okay, on the playground, RT, that RT represents, and that's another easy 2 mark. So let's just show you how you work this out quickly. Okay, my friends, so for part 3 here we're going to state that since, let me make a note for part 3. Here we're going to state, now when from a map, okay, from a map, when they ask you for the actual distance, okay, basically what they're saying, they have scaled down, they have made the drawing smaller to fit on the paper here. Okay, so basically what they're simply asking is that if they should put this in real life, actual distance mean real life, if they should put this drawing in real life, what would be the real life distance, okay, from those 2 points. Now basically from the scale, okay my friends, basically what they're saying here is that to every 1 centimeter, okay, is mapping onto 30 meters. Okay, hope you're getting that. All right my friends, and we got it from here 1 centimeters to 30 meters. That's what it stated there. So it simply means then my friends that if I wanted the actual distance from R to T, okay, RT is equal to, I would simply have to take my 6, okay, because if everyone is mapping onto 30, then that simply means I have 6 sets of 30, okay, meters. So I'm taking the distance RT and I'm going to say 6 multiplied by my 30, and this is equal to 6 times 3, that's 18, and I'm going to simply add a 0. So I would have 180 meters, and that's my answer. It's as easy as that, my friends. Hope that you found this useful. See you in the next video where we'll be finding the solution to part B. Bye bye.